In this example, we want to determine this voltage V1. Let's take a look at a variety of different ways of doing this. If we do KVL around this loop, call that loop 1, we have the voltage V1 in that loop, but we also need to determine this voltage and this voltage. So that's going to result in one equation, but 3 unknowns. Let's see if we can do something better than that. If we loop through here, call that loop 2, now we still have to worry about the voltages across the 1 ohm and the 2 ohm resistors. And in fact, the 2 unknowns that we introduce are not even the same 2 unknowns that we've got from loop 1, so we can't even combine these to reduce our number of unknowns. Let's see if we can take more of a clever approach towards doing this problem. If we create a loop that goes through here, call that loop 3, we go through 2 voltage sources, a 4-volt voltage source and an 8-volt voltage source, and the desired voltage V1. So we have one equation and one unknown. Now if I start down here, moving this direction, I enter the negative terminal of the 4-volt source first. If I assume that entering the negative terminal results in a negative voltage, this becomes negative 4 volts. Going this direction into the 4 ohm resistor enters the positive terminal first, so that will be a positive V1 contribution. And finally, going this direction into the 8-volt source, we enter the positive terminal first, so we get a plus 8-volt contribution. That brings us back to our starting point, so that sums to 0. If I solve this for V1, 8 minus 4 is positive 4, V1 is equal to negative 4 volts, and we're done with the problem. We don't have to worry about any other loops in this circuit.